Right, in question number 2, it says which product is irrational? Okay, so if I look at this chart up here, remember that our irrational numbers cannot be written as a fraction. They're non-terminating or non-repeating decimals, and they're not perfect squares. So if I look at each of these examples here, each of these choices, the square root of 16 and the square root of 9, those are both perfect squares. So my product is going to be rational. And you can always test this. So if you pull up your calculator and you actually type them in, so if I do the square root of 16 and I multiply that by the square root of 9, and when you press enter, if you get an integer, it's rational. If you get a decimal, it's going to be irrational, or if you're left with a square root, depending on how your calculator simplifies. And that's one way you could go through the list. So I could try the next one. I have the square root of 2 times the square root of 10, which would equal the square root of 20. And the square root of 20 is not a perfect square. So look at how my calculator here, it simplifies it for me, which is nice. But if you wanted to double check, I can show you. If I put it as a, oops, as a decimal here. All right, there we go. That took a long time. Sorry about that. So here you can see we don't get a perfect square. So your calculator might simplify like this as that decimal, or the first time you saw me go through, your calculator might simplify it as a square root. But if it doesn't give you an integer answer, it's an irrational answer. So I don't even have to keep going. B is going to be my correct answer. You could just do a quick check. 25 and 64 are both perfect squares, so we know that's going to be rational. And then the square root of 5 times the square root of 5, remember anytime we multiply something by itself, it's just the number inside. This would just equal 5. And again, if you're not sure, plug each answer choice into your calculator and see what you get.